Hello everyone, my name is Daraj Jamaru. Today I will show you groundwater flow modeling using MODFLOW under PMWIN platform. Once again, welcome to our channel. This tutorial is prepared for advanced level learners. The videos are consecutive ones, and today I will show you all the detailed process for grid size determination using steady-state flow simulation. Anybody wants a beginner's tutorial? Please visit our channel. For this exercise, the first step is creating our model. Just file, create new model. I just want to create under desktop, new folder, Lectana. Under Lectana, I can say it project 1. Save. Okay. The second step is under grid mesh size. We have to determine our mesh size. For this exercise, we will have number of layers as 1. If you wish, you can add 1, 2, 3 as you wish. Number of rows and number of columns and their model extent, and the coordinate system to our study area. So for my study area, I do have this boundary and the locations at each corner point, and I will input this to the coordinate system of the model. This is the inactive. We have to uncheck this and we can input these values. Before this, we have to set the number of rows. I want to have 400 by 400 columns and rows. I do have the coordinates of my study area, and so I will input to the MODFLOW. I have x1, x2, y1, y2, and 400 by 400. So this is 400 by 400 row column, and the model extent means x2 minus x1 under the y direction, and y2 minus y1 is under x direction. So for this exercise, y2 minus y1 is this number, and x2 minus x1 is this number, and we have to input these values. For C, this is a value of row, and this is a value of column. And we'll go to the coordinate system. We do have x1, y1, x1, and y1, x2, y2. So y2 means y0, x1 means x0. And so, okay, this is our mesh size. So leave it either, save changes to mesh size, yes. Yeah, this is create a number of rows 400 by number of column 400, layer 1, flow type steady state. So go to layer property. Layer property means that determines the aquifer property of the study area. An aquifer may be confined, unconfined, semi-confined, unconfined, and semi-unconfined. So the layer property are defined in the layer property dialog box for this study area. I preferred the aquifer type to be unconfined and I'll say it OK. But in many settings, this dialog box depends on the selection between the block centered flow and layer property flow package. When the layer property flow package is used, the columns transmittivity, decans, and storage coefficient are deemed to indicate their settings are ignored because the layer property flow package only uses horizontal hydraulic conductivity, vertical hydraulic conductivity, specific storage, and specific yield. On the other hand, when the block centered flow package is used, the column vertical anisotropy is deemed since it is not supported by the block centered flow package. So we have just determined our layer property. The next step is cell status. Cell status, as you see, has two parts: I bound for mode flow and IC bound for transport models, contaminant transport models. Since we are just simulating and processing mode flow, we will use I bound. This is our I bound. The flow model requires an I bound array which contains a code for each cell. A positive value in the I bound array defines an active cell, the hydraulic head is computed, whereas a negative value defines a constant head or fixed head cell. That is, the hydraulic head is kept constant at a given value throughout the flow simulation. On the other hand, a value 0 defines an active cell, no flow takes place within the cell. So 1 is an active cell, 0 is inactive, and -1 is for constant head. So we have to determine our cells. I have to go to value reset matrix 0 for the all mesh size. As you click on this, it shows 1 at every layer, row, and column. So we have to define our boundary. Go to options, map, and activate this box and right click on this file name, and automatically it goes to our folder. This is done. I want to add my boundary shape. Okay, this is my study area. I want to put the value of 1 inside the boundary and 0 for this part and -1 for the leg. I do have to also add the leg if you can also add the reverse, then okay. Yeah, this is a leg represented by -1 value, which is heroic head constant at a given value throughout the flow simulation, whereas positive value define an active cell in the head is computed. This is our study area. So we can draw using this switch to polygon input method. As much as possible, we have to follow your study area boundary when you are drawing. Yes, when you finish, you can right click inside your study area and cell status bound. It was formerly 0 and we have to change this into active cell number 1 and transpose this value. Okay, yes, here is it. In the same fashion, we can just see when the cursor moves out of the study area, it is not active. When it comes to the study area, inside of the study area, the shape size looks like this, and we can delete. In the same fashion, using switch to polygon input method, we can draw our leg boundary. This is our leg boundary, the so-called leg tunnel. Right click, cell status as -1. This is inactive. Sorry, this is the constant fixed head cell and transpose. Okay, this processing, yeah, it's just automatically change it, and you can delete this boundary and then leave editor, save changes, yes. So we're back to grid. We have just determined our grid size, and the left one is the top of layers and bottom of layers determination. For top of layers and bottom of layers, we have to just determine the top of layers of our study area using global mapper, using digital elevation model of the study area. So I will just use global mapper, go to file, open data files. I do have ETODM and yes. Yeah, this is digital elevation model. From this, I will extract my study area in surfer grid format. So I will go to file and automatically add my study area, Lake Tana Basin. Tana Basin. This is Tana watershed. Tana Basin. Here is it. Okay, just add the correct one. Open data. Tana watershed. Yes, this is the correct one. Can zoom in and zoom out. This is my study area. Before this, we have to go to the view, sorry, tools, and configure my projection as datum and projection. This is my datum is adding done and projection UTM. Just you can type U and it can automatically. Then zone will be 37 degree, bounding 36 east and 42 east, northern hemisphere, and I apply. Okay, the projection is automatically changed. So I'll just go to tools and digitizer. Okay, just click on this. It automatically defines our study area. If you wish to edit the area, you can right click on this area and edit the area feature, something like this. So I don't want to extract or crop this study area, so I'll go to file and export, because I am interested to export the elevation grid format. Export elevation grid as file type. Different file types are available, but I'm very interested, and that is suitable for MODFLOW is surfer grid as a format. Okay, then okay. So the sample spacing I just told you before, 400 by 400 is my interest. 400 by 400 meters, and go to export bound. In this case we have two options, either drawing a box just like this or using current projection. So I do have my current projection with emitters prepared. Select ANA coordinates. ANA coordinates. Okay. I will just add these values or locations to the mode flow, to the global map. So we can use y2 or x1 or x2 or y1 y2 of our study area, or we can also draw a box just like this. But care should be taken in order not to miss your boundary. Draw a box just like this. Okay, then okay, it automatically goes to the file that we have created, and just we can say lectana grid save. It is automatically extracted. Then we will go to our mode flow model, and the top of layers is our model. Then go to value, matrix. This is the value, but it's not inserted, so we have to load file mode flow lectana server grid lectana grid, open it, and you can replace this. Automatically it replaces, and I can save it as top Tana top save. So I will say okay, and then leave it editor, save changes to elevation of the top layer. Yes, I have set the top of layer. In the same instance, the remaining one is the top of the bottom of layers. Bottom of layers or bottom of aquifer, which is difficult to know exactly, and we will assume it as lowered by 2 meters from top elevation. That means top elevation minus thickness of the aquifer. So go to bottom of our aquifer and value matrix. This is parameter of bottom of layer. So we can load the top one. Sorry. Click down. Down at top. Open. Okay, replace. Okay. But the top of the bottom of the aquifer is lowered by, as we have assumed earlier, is lowered by 2 meters, so we have to minus 2 from the top. So value search and modify active. The minimum value will be 0, maximum will be any number which is greater than the elevation of the DM of Ethiopia, then value minus 2. Display add. Okay. Yeah. This is the value for elevation of bottom layer, bottom of aquifer. Then file, leave editor, save change to bottom layer. Yes. Yeah. We have just determined our grid size. Thank you very much for your watching. In the next tutorials, we will see the parameters name, mode flow parameters determination for each parameters, and the flow package under mode flow simulation, the flow package, terrain, evapotranspiration, general head, horizontal interbed, recharge reservoir, stream flow routing, time variance specified, well, within capacity. So please subscribe and like our channel to get newly released videos. Thank you.